we're often asked to find an equation of a conic section given some information about its graph. In this case, we're to find an equation of a hyperbola with given foci and given asymptotes. And as far as information we could be given, this probably makes this about as tough a problem as we could have, other than they've given us a really nice center to work with. So I like to sketch a quick graph of what they're talking about here. So foci at plus or minus 10, 0. So that would look something along the lines of this. And again, those are my foci. Therefore, I don't know where my hyperbola exactly is, but I do know for sure that it's opening to the right or left in an x direction. But again, that could be a lot closer to the vertex of the hyperbola, could be an awful lot closer to 0, or it could be tighter up against 10. But foci 10 and negative 10. They have given me some information, and we talk about parts of hyperbolas that are important for us to know. We'd like to know our value of A. We'd like to know B. Perhaps C might be helpful to us. We also need to know HK, our center, and we need to know direction. Are we right, left, or are we up, down? So giving me the foci gives me some of this information. Pretty nice. If we got the foci, we've got our center. In this case, very nice and convenient, 0, 0, but there's some inconvenience coming our way. If we're given the foci, I often say you can't spell focus without a C. So they give me the value of C, which is the distance from our center to our focus, in this case, 10. And they also tell me that this guy's opening in an x direction. This is what I would refer to as an x squared hyperbola. So here's what I have right now. This guy is x minus 0 squared on a squared minus y minus 0 squared on b squared equals 1. But I don't have enough information for a or b yet. But focus gives me that much. So now I have to consider this guy, and maybe I'll draw a sketch of this in to give me some idea what we're talking about here. So if I scale this sort of appropriately, I know that I would have to go, for this slope of 3/4, I would have to go up 1, 2, 3 and over. Let's see, if I called this 5, let's see how I do here. 1, 2, 3, 4, 5. I know that my asymptotes would be up 3 and over 4, or down 3. That's 5. 1, 2, 3, 4, 5. Down 3 over 4. Or they could be up 3, left 4, or down 3, right 4. So my asymptotes of this want to look like that. Okay. What it doesn't tell me, though, and here's where people might make a mistake. They may think, well, then to build my box, that must place the vertex right over here at 4. I'm not so sure of that. But I do know that in the process of building my box, to get to my vertex, I would be going over A. So I'm going this direction A, and I'm going up B. And I know that up B on A is my slope, and that better be plus or minus 3/4. Well, how is that helpful for us? I know a little bit about A and B. They're not necessarily 3 and 4. They're just in ratio 3 to 4. And I know a little bit about C, but I know a little more about A, B, and C. In a hyperbola, I know that C squared equals A squared plus B squared. I could easily solve this expression for B and get, if I solve it for B, I'm going to get B, not A, and get B equals 3/4 A. Well, how is that helpful for me? Come back to this equation. I know C is 10, so C squared 100 equals A squared plus, in place of B, I could put 3/4 A squared. And now I can find A. Once I find A, or A squared, then knowing C and knowing B as well, I should be well on my way to coming up with my missing values. And I'm going to leave that to you.